Good day everyone, I'm Mark Alvin Paloma Montino and I'm here for presenting my research paper to our Mapua course in graduate school, EMG 218, Quality System Management. So without further ado, let's begin. The research entitled Investigating Water Leakages for Proposed Luxury Hotel Building in Doha, Qatar, using Six Sigma tools. The contents of this study are introduction, methodology, results and discussion, and lastly, conclusion. First, let's tackle the abstract of this study. Water leakage is an issue that we may encounter during the construction process, or more specifically, at the finishing stage, especially if your construction site or location is close to the sea. The steps of define, measure, analyze, improve, and control are part of the Six Sigma Quality Improvement Method, or DMAIC. These tools assist the construction industry in reducing the occurrence of water leaks during the building and finishing stage. This article is based on the case study of a renowned Qatari construction company. This company is constructing a hotel building that experiencing water leaking issues. This company was losing money due to the rework caused by the leakage and at the same time failing to meet the handover deadline since this hotel building was supposed to be open before the PIPA 2022 here in Qatar. Six Sigma was the tool implemented to reduce work or rejection by eliminating process variation. Then let's proceed with the introduction. Background of the study. In industry of construction, water leakage is a common cause of loss for construction firm owners when a site is being constructed. Capillary action frequently causes water leaking from below via soil and masonry. Types of external sources include rainfall, water pressure put on structural element, and those members' incapacity to sustain such pressure. Internal water sources, including leaky plumbing fixtures, connections that have broken as a result of poor water system, waste and sewer lines, and internal water sources, including connections that have broken. Whatever the cause, company owners must take certain precautions to avoid such losses, even if insurance covers the damages. Building industry owners may incur financial difficulties if water leakage happens. Such charges can dramatically erode business margins and cause building timetable delays. Adopting a preventive strategy is essential for avoiding water leakage. Business should work on decreasing building faults to reduce the danger of water leaks. Debris cleanup, delay charges, rework fees, property damage, and ultimately reputational harm are all examples of such costs. They claim that prevention is better than cure. In building, preventing damage is even less expensive than repairing it later. Water leakage may be avoided by concentrating on quality and conducting systematic planning and testing throughout the building project. On this study, coring tests were carried out by collaborating with a private sector engineering organization in Qatar. The geotechnical group who would act as a third party to execute the needed tests on poured concrete in the leaking areas. The results will be documented to show whether the affected areas are compromised in terms of concrete strength and stability. The findings will also justify whether the company will recommend a competent waterproofing system to prevent water from entering the building through affected areas or the water leaking location. Significance of the study. It is challenging to pinpoint the precise cause and sources of the structure's water leakage. Water flows via an invisible system of capillaries, air pockets, and permeability pathways that cannot be seen or traced back to the original source. Water may enter from one location and become visible at another. As a result, before implementing Corrective actions. The various sources of leaks should be identified and understood. It is likely that inhabitants may experience discomfort as well as unsightly looks, unhygienic conditions, and occasionally sicknesses. If concern is not made to their prevention at every stage of the design process, implementation, and management, even fixes that are out of reach and impractical. The researchers believe that Six Sigma, DMAIC, or DMAIC might tackle the lingering problem of water leakage in the construction industry. Also, with correct DMAIC implementation, businesses may have benefited in a number of ways, including reducing the cost of poor quality, increasing revenue, and overall enhancing corporate performance and efficiency. Furthermore, the research identifies a necessity to solve this issue because leakage is one of the major issues in many structures, not only during the construction phase, but also throughout the completing the stage. Objectives of the study. To be successful in a developing country like Qatar, companies must continually improve their procedures. Offering high-quality goods and services has evolved into a competitive edge, as well as a necessity for sustainability. Organizations utilize a variety of methods to strengthen the services and quality of their products. One such approach is DMAIC, a problem-solving methodology created by Six Sigma. This study aims to show how Six Sigma and DMAIC may be experimentally used to eliminate product defects brought on by water leakage from one of the projects of a reputable Qatari construction company, China Railway 18 Bureau Group, WLL. The in-depth research focused on cases of water seepage or leakage at the proposed luxury hotel building at basement areas, where the DMAIC tool would be utilized to ensure that similar water leakage concerns do not emerge in the future. Now let's move on with the methodology. The DMAIC technique was taken into consideration since the research aimed to enhance the current business process. The DMAIC approach takes a situation that a company has defined and applies a number of tools and strategies logically to find a long-term solution in order to put the company in a competitive position. The paper applied the DMAIC approach to systematically investigate issues' fundamental causes and provide a solution to lessen or eliminate them. This research will concentrate on water leaking in basement areas. Water seepages and leaks in basement are time-consuming and expensive to repair. Extensive study has been conducted to examine the nature of the problem, its underlying causes, and potential remedies. Figure 1 depicts how to understand DMAIC or DMAIC technique. For the data collection, the research focused on incident of water seepage leakage at one of the construction sites in Doha, Qatar, the proposed luxury hotel building, from May 25, 2022 to June 11, 2022, specifically in the basement 3 area where the leakage occurred. The researcher collected a sample of cored concrete specimen and sent this to a third party to perform the required test to establish the strength and stability of the concrete. Data collected will use to analyze the concrete problem. Furthermore, the study focused on how to resolve the problem of water leakage on the construction site. For conceptual framework, this study uses DMAIC phases as a framework of the research. Refer to Figure 2 for the conceptual framework of the study. We will go through the DMAIC phases in more detail on the next slide for better understanding. For all the data that we gathered, let's move on to the results and discussion. The goal of this study is to use 5 procedures in connection to water leaks to improve and optimize the construction processes and outcomes. The study discovered and used the following 5 steps in the construction process. First is the define. The project boundaries and purpose are attempted to be established at this phase, together with the client's viewpoint and the project objectives. However, before this part of the project can be established, the Six Sigma team must be constituted. The team for this improvement project include 3 people: a project manager, an experienced mason who would repair the leaks, and a quality engineer. According to Henry and Nota Lirac's recommendation, a Six Sigma scheme should be chosen based on the business difficulties, such not meeting customer expectation. The chosen initiative should aim to have a large and beneficial influence on consumer while also generating financial savings. This theory states that the project chosen problem was to minimize and remove quality deficiencies, such as water leaks in basements, which certainly has an impact on customer requirements as well as substantial cost reduction for the organization in question. Furthermore, Fande et al. State that listening to consumers is crucial for business success in order to determine the aim of the particular project depending on client needs. Customer reviews entails learning what customer want and evaluating specific expectation shown in this project. Furthermore, it ensures that moving ahead, the development team and organization will continue to put their major attention on the project problem of defect elimination. The project boundaries must also be set and distinctly stated in order to ensure that the study is in charge and focus solely on the project topic. Water leaking in basement 3 was the only thing that this investigation was intended to cover. Because leaks have historically been the most common issue in construction, the development team and organization choose to concentrate their early efforts on this particular issue. This decision was also made because chemical injection alone cannot effectively rectify the issues. Last but not the least, a project plan document used to record the project goals and other essentials from the outset was used to explain and illustrate the data design of the project. In other words, the project plan summarized the project name, background information, goal, customer feedback, limits, group members, and financial advantage to be expected, and benefits envisioned to customer, which is shows in table 1. Next phase is measure. This stage of the problem-solving process entails developing precise measure to help track advancement towards the objective, which in this study was to reduce the quality defects in the basement area, namely the water leakage. The measure phase in this project explicitly referred to the development and selection of acceptable metrics for locating the main issues that required attention. To guarantee that the data was gathered effectively, a collecting strategy was established as well. One of the measures proposed was simply the testing of the concrete cord on the affected area of leakage. These parameters were the process sigma level and the quality level, as determined by defects per million opportunities, or DPM. Following the definition of the defective concrete test result, the DPMO and sigma level of the concrete with water leakages were determined. According to the record of the company, there were one major type of defect that contributed to the water leakage. The improper application of chemical injection was the one major flaw. The leak defect was characterized for this study as basement flooring with a water leak appearance on the surface, and so this water leakage area is submitted to quality testing. If the quality test on cord concrete fails, it is possible that they may chip more concrete and take another sample for testing until the test result is passed. The test result data was gathered over a few days. Figure 2 and 3 is the full detail of the test report. And Table 2 summarize the findings. For this test result summary, you can see that we have 5 numbers of sample and sample B is cancelled as per consultant request. Furthermore, as we see from the table, all sample actual strength is passed compared with the required strength, which means no more additional cord sample test is required. The next phase is analyze. In this phase, the water leakage in basement 3 is widespread, and it is unknown whether the chemical injection will be successful in all affected areas. In order to effectively identify and address this issue, the company, or perhaps the site, will first perform an analysis of data, guided by an investigation to recognize and comprehend problems' underlying causes. To further understand the cause of the water leak, the analytical part of this strategy was generated from the fishbone diagram, which is a methodical questioning methodology for identifying the root causes of problems by creating a link between an effect, all probable causes of that impact. When complete, the diagram gives recommendation for future growth and assists in identifying the underlying problems. The mentioned potential underlying reasons are shown in a cause and effect diagram in figure 4. The main cause will be the water leakages and the effect for each category, which is man, machine, measurement, materials, methods, and environment. The next phase is improve. This phase, which follows the discovery of the underlying causes, seeks to pinpoint remedies to lessen and deal with them. In the improve phase, which is referred to as a statistical method for examining the effects of several elements, schematics suggests a statistical method for examining the effect of several elements needs employing experiment designs. Montgomery claims that increased process productivity, reduced variation, and lower total cost are all the advantages of studies. After receiving the test result and taking action to address the water leaking issue, it is possible to draw the conclusion that the probability of similar defects occurring will be minimized. The improvement also shown that the Six Sigma and DMAIC issue solving methodologies could be used efficiently and effectively to reduce the number of defects and hence increase productivity. Figure 5 assess the outcomes of the improvement project mentioned in this paper, from before improvement to after improvement. The last phase of DMAIC process is control. Control method, frequent performance assessment, increased follow-up quality, and enhanced process standardization and documentation. The practices have been standardized to ensure that similar issues do not arise in the future. It is addressed how Six Sigma DMAIC may be used to improve the quality and efficiency of building projects, as well as to reduce the need of major structural repairs as a result of water leaks. System analysis is conducted at this point of the improvement technique. And last, for the conclusion. This research provided a successful case study of how to lessen defects in a construction company's water leaks by utilizing problem-solving technique of DMAIC and the concept of Six Sigma. Because of this, the results may be applied by the construction project as a guideline for implementing certain effort for continual improvement in their companies, such the one discussed in this paper. Following the analysis conducted during the analyze and improve phases of the DMAIC, the initiative reported in this study showed that the early detection of water leakage and accurate repair of it by injection had a statistically significant impact on lowering the cost of work quality. Taking all of this into consideration, a decrease in the number of defects was achieved by determining the concrete test report of poured concrete and implementing remedial actions after receiving the test result. Furthermore, this study was a pilot project meant to experimentally show that the China Railway organization that DMAIC problem solving and Six Sigma methodology are efficient ways capable of enhancing its poor quality and cost saving by effectively addressing the water leakage defects. This demonstrates that the advantage like higher revenue, better business performance, higher quality products, and higher customer satisfaction are anticipated, as long as the company maintains its embrace of Six Sigma within its continuous improvement, and employs its concept and core principle to methodologically address quality issue. And that is the end of my research paper. Thank you and have a good day.